You tap a button, the loading spinner pops up, and it just sits there. The app hangs. Most developers look at this and immediately blame the server, assuming they need a bigger, faster machine to process the request. But the server usually has plenty of power. Behind that simple dashboard, the application secretly asks the database for 10,000 records. This is greedy design. The API is returning unlimited data, unused fields, and background junk. All this invisible bloat eats up server memory. Before any useful information reaches the user, it gets rammed into the network pipe, causing a massive digital traffic jam. There is a golden rule in system design to prevent this. Never return an unlimited dataset to the client. Applications rarely collapse because they have too many users. They drown in the invisible waste of their own unconstrained data. The primary defense against this bloat is pagination. It's the mechanical process of taking a massive, unmanageable dataset and slicing it into small, predictable chunks. Look at this side-by-side comparison of API requests. A naive request asks for everything at once, creating a chaotic, endless wall of data. A properly structured API request, however, enforces strict boundaries. It explicitly asks for exactly 20 items on page 1. On the front end, this structured approach is what actually powers the smooth, seamless experience of an infinite scroll. When you open Instagram, the app doesn't attempt to download the platform's entire global feed. It requests just the next tiny, isolated grid of images. But even simple pagination hits a wall at scale. Traditional offset pagination works by counting records page by page, which forces the database to scan thousands of previous entries just to find the next batch, wasting precious time. To fix this, large systems use cursor-based pagination. A cursor acts as a unique, precise bookmark. It allows the database to instantly jump to the exact location of the next data chunk without having to recount a single previous record. By transforming an unpredictable data load into uniform packages, pagination protects your server's memory and keeps the network bandwidth clear. Controlling the size of the data chunk is only half the battle. You also have to limit the scope of the information you pull. A common architectural error is pulling an entire block of raw data from the server and relying on the user's phone or browser to sort through it to find the relevant pieces. The mechanical cost of this mistake is severe. You are transmitting useless data across the network and forcing the mobile device to burn its own CPU cycles just to hide irrelevant records from the user. The correct architecture solves this immediately. You pass strict filtering parameters directly into the API request, targeting specific data before it even touches the network layer. The database does the computational heavy lifting. It searches, filters, and transmits only the exact shapes requested. Pushing the filtering work down to the database drastically reduces unnecessary data transfer. This ensures the app remains instantly responsive, regardless of how massive the total dataset grows. In the modern tech landscape, this problem is multiplying. AI code generators are accidentally mass-producing the exact greedy designs we just broke down. An AI will happily write the code for a flawless, beautiful user interface, but it will support that UI with a naive, unconstrained backend that casually asks for the entire database on every load. This is a dangerous trap. The flawed system will look and perform perfectly during local testing on your laptop because it's only loading 10 dummy records. But when that unconstrained AI-generated code hits production and suddenly attempts to load data for 1 million concurrent users, it triggers a catastrophic failure. To avoid this, you need a senior engineering mindset. You must explicitly command your AI tools to implement pagination and filtering in every single API contract they write. True system scale isn't achieved by throwing money at a faster server to process terrible requests. It is achieved by designing systems that strictly, predictably, do less work.